Hi, my name is Katie, and I'm a cloud platform engineer for Conde Nast. Around 1.5 years ago, I joined Conde Nast to contribute to a project that aims to create a centralized, globally distributed platform that has Kubernetes at its centerpiece. Today, I would like to talk about ClusterAPI, more specifically, what's the usage of this tool in our ecosystem, and I'm going to provide a guide on how to get started with this tool. Before I move on with the topic, I would like to ask some questions, just to make an understanding of the audience here. How many of you have heard about Kubernetes? How many of you are using Kubernetes in production? How many of you have heard of ClusterAPI before? Did anyone try to use it? No. And I have a question maybe. How many of you know what Conde Nast does? So, quite a few people. Right. So, I'm just going to give a bit of introduction of what Conde Nast does and kind of provide this use case, why exactly we use Kubernetes and why exactly we want to prototype ClusterAPI. So today I'm going to talk about ClusterAPI. I'm going to talk about the workflow and the concepts and components it introduces. So let's begin. Conde Nast International has set the benchmark for print and digital publishing for more than 110 years. We operate brands that are fashion and luxury oriented, and you might be familiar with some of the brands like Vogue, GQ, Wired, and you have magazines just over there. Vanity Fair, ADM, and more. These are just a few of the brands we have in our portfolio. With headquarters in London, we operate on an international scale in more than 11 countries. We have 62 websites overall, and they generate 200 million unique users every single month. So far, we reach a total of 1 billion page views every single month. This means that every single second, we deliver 25,000 articles to our users. It is quite a considerable customer base we have out there. Now, I mentioned that we operate in 11 countries. However, if you look at the map, we can see that they're quite geographically dispersed. Historically, all these markets, they actually had a lot of inconsistencies in the tech stack they kind of use. This includes the systems to deliver the live traffic and the visual and design, because the Vogue in France, for example, is going to be quite different from Vogue in Italy. So we kicked off this project to create a global platform, a unified platform, and we actually distributed it across the globe in 5 different regions, making a total of 9 Kubernetes clusters. We have 3 clusters in Europe, a dev, staging, and a production one, to deliver the content for our European markets. The cluster in Tokyo is going to deliver the content for our Taiwanese, Japanese, and Indian customers, while the cluster in North Virginia is going to deliver the content for our Mexican market. In China alone, we have 2 dedicated clusters, a staging and a production one, while in Dublin, just over there, we have 2 more clusters to host our internal tools. Now, as you can see in Russia, which kind of covers a very big part of our market, we do not have a replica of our tech stack. This is because the current strategy is to serve the content from our European markets while using a CDN, which is Russian-oriented. This will ensure our service availability in Russia while investing minimal engineering effort. Now, I would like to put a bit more focus on China and Russia. From these 2 countries alone, we have 70 million unique users every single month, and they represent 30% of our entire digital readership. It is a very considerable customer base, and we have to be prepared technically to meet the demand in these areas. However, if you work in infrastructure and delivering platforms and clusters in these 2 countries, you'll know that it's actually very challenging to provide an infrastructure in these countries. In our example, when the project for a unified platform was kicked off, we did not have a clear vision of one cloud provider that's going to be used for all platforms and all regions. This kind of enforced our decision to go with a self-hosted Kubernetes solution. And I would like to focus a bit more on our Kubernetes clusters. Now, Kubernetes underpins the entire infrastructure of Conde Nast International. We are a CoreOS house, meaning that we're using Tectonic installer for our cluster deployment, and we're using etcd for the storage of our cluster data. Using Tectonic allows us to plug it into different cloud providers while having a self-hosted solution for Kubernetes. At this moment in time, actually, we are using Tectonic in combination with AWS, which allows us to create our clusters in pretty much all the regions, including, well, in the future in China as well. Now, I mentioned that we're using Tectonic. However, Tectonic is no longer under active development and is to be converged with Red Hat OpenShift Container Platform in the future, which means we cannot use it anymore for provisioning of our future clusters. Now, when you talk about bootstrap tools for Kubernetes, we have a bunch of them. We have kubeadm, we have kubespray, we have kops, Tectonic, and many more. There are like literally a lot of them. Over the years in the ecosystem, there are a lot of tools emerging to provide this bootstrap capability. However, if you look at the cloud providers, every single tool is supporting, it's going to be difficult for us to find that common denominator. What I'm actually trying to say here is that if we use Tectonic to provision our cluster in AWS, and if I use, for example, kops to provision my cluster in AWS, the way I'm going to do that is going to be completely different. As well, we will not have all the cloud providers supported by one single tool. We'll have to use a combination of them. So for example, if you want to use Kubernetes in Azure and have it in a self-hosted solution, you'd use one of these tools, but it's not going to be the same tool if I would like to provision my Kubernetes cluster in China. So what I'm trying to say here is like there is no one tool that would actually provide this interface to create clusters in different infrastructure providers. Up to the point, we have ClusterAPI. Now, when you're talking about ClusterAPI, we talk about a set of declarative API endpoints that actually aims to manage the life cycle of a cluster. What I'm actually meaning here is the creation, scalability, management, and deletion of a cluster. All of this is done through one common interface, and you can plug it into different infrastructure providers. Sorry, my voice is like, whew. While I'm talking about ClusterAPI, we're talking about a SIG cluster lifecycle, which appeared in April 2018. They had the first release then. So it's been around for half a year. It hasn't been very long, but it has a lot of success and kind of interest from the community. The current release is V1 Alpha 2, and they're actually going to release V1 Alpha 3 very, very soon. So I was talking about the infrastructure providers that integrate with ClusterAPI. Currently, there are around 15 cloud providers that are actively developing this interface for cloud flow through ClusterAPI. From them, we have Google Cloud, AWS. We have Baidu Cloud, which is a Chinese provider, very important here. We have Bare Metal, we have DigitalOcean, and many more. These are just a few of the providers. Now, let's look at the workflow for ClusterAPI, how exactly it works underneath. Supposedly, we would like to create a bunch of clusters in different infrastructure providers, different regions, pretty much no restriction. We just want to create them, but at the same time use the same manifest with minimal changes to them. So the way ClusterAPI works is going to introduce the concept of a management cluster and a target cluster. Now, the management cluster is going to be actually where all the components are going to be running to provision clusters subsequently. Now, for testing and developing purposes, it is recommended to use Kind. Now, Kind is a great tool to provision Kubernetes clusters locally, and you can do this through one command. And actually, I'm going to use one of the Kind clusters to demonstrate how ClusterAPI works. If you'd like to use ClusterAPI for a more sustainable solution or something which is a bit more closer to production, it is recommended to use an existing cluster just to make sure you have it available at all times. So, management cluster actually requires 3 controller managers to be up and running at all times. And these are them. So 3 of them are the ClusterAPI CRDs, the bootstrap providers, and the infrastructure providers. The ClusterAPI CRDs are going to pretty much have all the configuration required to actually deliver this target cluster. The bootstrap provider will make sure to translate the configuration into cloud init script, which will be attached to your instance, and subsequently your node or instance in any cloud provider is going to be added to the Kubernetes as a master node, or like as a work node. The currently supported tools for the bootstrap providers are kubeadm and Talus. And we're talking about the infrastructure provider. These are pretty much the 15 providers I was talking about. Well, I was talking about a few of them, but the list is quite big. So here we're actually going to have the controller managers for example, GCP, AWS, DigitalOcean. This will actually interact with the API endpoints of the provider and actually create the infrastructure. So for example, with AWS, we're going to create our VPCs, we're going to create our load balancers, EC2 instances, and so forth. This controller is going to be responsible for that. And once we have a management cluster with all the required dependencies up and running, we'll provision our target clusters. Now this is pretty much what we actually want to have, and this is what we're going to give to our developers to run the application on top. So this is going to be the end result. So let's look at the ClusterAPI components. What I really want to focus here is how we create the manifest for ClusterAPI. And another thing which I would like to make, a point I would like to take across, is the fact that ClusterAPI manifests are quite, how can I say, quite standard. The changes you need to make between the cloud providers is very minimal, and I'm going to show that. But before, let's talk about these available CRDs. Currently, we have 4 available custom resource definition for ClusterAPI. We're going to have cluster, which is pretty much going to have all the configuration required to deploy Kubernetes cluster. This usually is going to have the CIDR for the pods and services, the DNS prefixes, and so forth. The machine resource is going to be very similar to node configuration. This pretty much will include things like what Kubernetes version you want to run on that specific node or cluster, let's put it this way. If you'd like a specific instance type for that machine, everything related to how exactly we want to create the machine in the cloud provider, as well as how we want to attach it to the cluster. Machine set is going to be very similar to replica set, which means that it's going to make sure that an amount of machine resources is going to be up and running at all time. And machine deployment is very similar to deployment, and it will reconciliate any changes between 2 machine sets using a very powerful rolling out strategy. Now let's look at the actual manifests. So I'm going to focus on the cluster and the machine manifest specifically. I think it's like pretty much the most important kind of bits in ClusterAPI. I know, can everyone see this, by the way? Awesome. Now, this looks very verbose, but I would like to draw the attention to the kind, which actually sits a cluster. And obviously in the spec section, we have the CIDR for the pods, which is here a subnet. What I would like to draw attention, actually, can I use this? No, I cannot use. I was trying to use my clicker and pointer. Right, so we specify our CIDRs for our pods, and supposedly we'd like to create this cluster with this specification in AWS. The way we're going to do that, we will have this infrastructure reference, and this is how it's going to look like. So the kind is going to be AWS cluster. We have a name for this specific resource, and at the spec we actually specify how exactly we would like this cluster to be created in AWS. So in this instance, we have 2 parameters, and we say we want the region to be US East 1, and we have an SSH key name, which is going to be default in this case. Now, once we actually deploy that to our cluster, to management cluster to be more specific, the end result is going to be in AWS, we're going to have a VPC, a load balancer, and a bastion. Now that bastion instance is going to be responsible to accept the external traffic to our cluster. And obviously to that instance, we can attach this specific SSH key. Now, if you'd like to create our cluster in GCP, this is what we're going to have. Obviously the kind is going to be GCP cluster. However, the parameters are going to be a bit more specific to the cloud provider, which kind of makes sense. Now, the region is going to be again US East 1, and we can specify things as the project name, which is very common for the GCP kind of ecosystem, and we can specify the network name as well. The list can go on and on, but what I'm trying to say here is that the infrastructure reference is very straightforward, and it's at the same time very specific and tailored and custom to a cloud provider. And if you'd like, this is going to be kind of an inception here, but if you'd like to create a cluster in Docker, which is going to be kind pretty much, this is what you're going to have. What you need to specify is pretty much the name of the resource and the namespace you want to create this specific resource. Now let's look at the machine. Machine is going to be slightly different because in addition to the infrastructure reference, it will require the bootstrap configuration. So how we actually going to attach this machine to our cluster. So let's look at one manifest for the machine. So the kind is going to be machine. We're going to have the bootstrap configuration, and in this particular case, we're going to use kubeadm. And we're going to have an infrastructure reference as well, but this is going to be more specific to how the instance is going to be configured. Let's look at the bootstrap configuration. So kubeadm. Now with kubeadm, we can invoke two operations with ClusterAPI, init and join. Now, when you have this init operation, it is actually going to create a cluster with one master node. This is what we're trying to say here. So we have this init configuration. We attach the instance we created in AWS, specifically here. And then subsequently, we specify the cluster configuration, and it's going to be more about external parameters and specifying it's part of AWS. If you'd like to add more workarounds, instead of init configuration, we're going to have a join configuration. And I'm going to show this during the demo. And the infrastructure reference for a machine resource is going to be slightly different. So the kind is going to be AWS machine. We can specify the instance type. So in AWS, we have T3 large, we have C5X large, any type you can actually add it there. We will attach an IAM instance profile to our machine as well, just to make sure our machine cannot do more or doesn't have more permissions, which will create damage to our AWS ecosystem. And again, we can attach a SSH key to our instance to make it more secure. I think it's time for demo. Right. I'm gonna ask if everyone in the back can you see the screen? Can you see what's written on the screen? Right, let me make it slightly bigger. Right. Maybe just that, because bigger is going to be too much. So what I actually have here, I already have a management cluster with all my dependencies up and running. So my management cluster is a client cluster, which is pretty much Kubernetes and Docker. So if I do a docker ps-all, I'm going to see my kind. Actually, I'm running a management cluster, which is 115. So you actually have seen all the namespaces. Now what I'd like to draw attention towards are these 4 namespaces. Now why I'm saying that is because these are pretty much where the controller managers are running. The demo today I'm going to show, I'm going to provision an AWS cluster and a Docker cluster. So what I actually have and what I require is a controller manager for our ClusterAPI CRDs. This is going to be contained by CAPI, which is pretty much ClusterAPI system. It will reconcile any changes we do to machine, cluster, machine set, and machine deployments. Now, the way I'm going to provision our clusters is going to be with kubeadm. This is going to be that specific controller manager. We actually, in that namespace, we're going to have the actual controller manager, which is going to make sure to make this joined and init configuration operations. And because I'm going to create my cluster in AWS, there is a provider for that. So this is going to be ClusterAPI AWS provider. And I'm going to have one for Docker, which is going to be ClusterAPI Docker provider. So if I do, actually, if you would like to see the controller managers, I'm going to get all the pods and namespaces. So as you can see, I have these controller managers running. So all 4 components, free plus Docker, which is going to be an extra infrastructure provider. So without any further ado, let's create some clusters. So in the management cluster, I'm going to do kubectl, get all my clusters. Ooh. I have none of them. And if I do get machines, I have no machine, so I have nothing deployed. Now let's deploy first I'm going to deploy this, and then we're going to look at the manifest file. So kubectl apply-f. From Docker, I would like to apply my cluster configuration. Now if I look at that, this is what we're going to have in our cluster, very similar to what we've seen before. So we specify our pod CIDR, and then we specify an infrastructure reference, which is going to be Docker cluster. And if I look at my Docker cluster, I'm just saying I want a Docker cluster. The configuration is very minimal for this one because it's a Kubernetes provisioned on the local machine. Now, if I do kubectl get clusters, I have a ClusterAPI Docker, which is provisioned already. Now, because I know this is in Docker, which means it's on my local machine, I can see this in my Docker containers, I would say. So if I do docker ps-a, I'm seeing this, which is pretty much providing this load balancer to our clusters. This is going to be the first thing that is going to meet the incoming traffic. So we have the cluster infrastructure pre-provisioned. What we actually need to do is to attach instances to our cluster. To do that, we're going to create a machine instance. So if I do a kubectl, apply my Docker control plane, not cluster, control plane. Now let's look at the actual manifest. Now this is a bit more verbose, mainly because we have more configurations we have to attach to this. So what I would like to focus on, this is pretty much what we've seen in the slides. So here we actually have a control plane, or pretty much a master node we would like to provision. We specify the version of Kubernetes which we want to run, which is 1.16.1. Ignore the comment over there. I was trying with different versions. And I was mentioning before, we need to specify the bootstrap and the infrastructure reference. So the bootstrap is going to be, again, kubeadm configuration. We're going to look at it in more details. And the infrastructure is going to be Docker machine, which I think is going to be very, very straightforward. So let's look too low. So the Docker machine, the infrastructure reference, is going to be very straightforward. I'm not going to concentrate on it too much. However, I'd like to concentrate on our kubeadm configuration, which again we invoke here and init. Can everyone see this one? Like the plants and everything. We invoke an init configuration and we're saying attach my new container from Docker to our cluster. And once we deploy that, what we actually need to see, because it's Docker, we'll be able to see a new container, which is this one over here. We can see it's a control plane, and it's actually running kind version 1.16.1. If I do kubectl get machines, I'll be able to see it over there, and it's up and running. Now, let's actually connect to this is going to be our target cluster, to which we have a control plane. Let's actually connect to this and see what we have over there. So to do that, with ClusterAPI, we actually have the kubeconfig stored into a secret. I'm just going to get that and connect to it pretty much. So, to do that, yes, just going to do this. Now if I do kubectl with my kubeconfig, which is going to be docker kubeconfig, I'm going to get nodes. I can see, sorry, let me do that again. I can see that I have one master instance, which is not ready. It is not ready because we don't have a networking layer. So what we're going to do, we're actually going to deploy Calico on top of this. So, yeah. I'm not going to go into Calico. This is going to be like all the resources we require. Now, if we get our nodes again, actually what we can do, we can get pods in our kube system. We actually can see that Calico is starting to be provisioned. It's actually pending over here. Once this is going to be ready, our nodes are going to be responding as well, which means we'll be able to actually accept workload. And as you can see, it's ready. Now let's attach some worker nodes to our cluster. So I'm going to do a kubectl apply. I'm going to have Docker and worker nodes. If I look at the file, now this is going to be very similar to our control plane. The only difference here is instead of actually creating one machine instance, I'm going to use a machine deployment because I would like, well, in this particular case, I want one replica. I'm not going to look at the bootstrap. Actually, I'm going to look at the bootstrap configuration because it's going to be a joint operation. So what we say here, we want a worker node, one replica of it. We want to attach it to our cluster, which is, we do this through labels and selectors, which is a very powerful mechanism in Kubernetes. Again, we say we want our node to be 1.16.1. And let's look at the actual bootstrap configuration. So here actually what we have a joint operation because we have a cluster. What we say to kubeadm, do attach this instance to my cluster. So if I get my nodes, I'll be able to see two of them, from which one of them is a worker node. And if I do a kubectl into my management cluster, and I get all the machines, I'll be able to see two of them. One of them is going to be our master node, and another one is going to be our worker node. And this is how I provision the cluster with Docker. But this is kind of very straightforward because this is like on our local machine. How do you actually do that with AWS or GCP? The current example I'm going to show is going to be AWS. So I'm going to provision it because it's going to take a bit of time to get everything ready. And then we're going to go through the actual manifest. So very similar, kubectl apply AWS cluster. And let's look at the actual manifest file. This is again, I actually use the example we have in the slides. So I used the same cluster network for our pods. And in our infrastructure reference, I specified I would like this to be in U Central 1 region, and I'm attaching a K8s bonsai SSH key to it. Now, if I get all my clusters, I'll be actually able to see that it's provisioning. And what exactly AWS is going to do in this particular case is going to create a VPC, and it's going to create a bashing instance. So we actually can see it if my session didn't expire. Right, so let's look at the VPC. And we have two of them, usually we have one. So we actually have this CAPI AWS VPC. So this is going to be provisioned already by our cluster. These are, well, how can I say? With every single provider, you have a set of default configuration you can use. You can actually obviously tailor it and custom it if you'd like, but this is going to be the default one with the AWS provider. And if you look at our instances, very soon, it's going to take a couple of minutes. Well, for the moment, let's just wait. Meanwhile, actually, what we can do, we actually can look into how we actually can provision the control plane in AWS. So to do that, let's look at the control plane. Now, with the control plane, again, what they actually provision here is a master instance. The difference here is, however, I would like to run a Kubernetes 1.15 instead of 1.16, so I can provision Kubernetes in different versions, different cloud providers. They're quite independent. And again, in my infrastructure reference, I can specify settings like the instance type, the IAM instance profile I would like to attach, as well as the SSH key. All right, thank you. And the init configuration is going to be slightly different from the Docker. It's going to be a bit more verbose, but this is again the example I've used in the slides as well. We attach the instance what we're going to be creating in AWS, and we specify extra arguments for our kubeadm configuration, which is the API server, the controller manager, to be related to AWS. Now, let's look at our cluster. It's provisioned. So I should see a bashing machine over here. I'm not sure if people can see this. Oh my God. This is what I'm talking about. It's still initializing actually, but that's fine. We actually can, at this moment, provision our control plane, so we can create our master instance. So kubectl apply our AWS control plane. So now when I do kubectl get machines, I'll be able to see an AWS control plane, which is actually provisioning. So this is going to take maybe two minutes or so. Or no, it's here. It's already there. Sometimes it's quick, sometimes it's not. Depends on the demo. So now if I get my machines, I actually see that's actually provisioned. I know it's like the indentation goes down the line, but it's provisioned. So what we actually can do now is we have a second target cluster and we can connect to it. I'm going to do the same thing. I'm going to extract the kube configuration to be able to attach to this. And I'm going to provision my networking layer with Calico as well. So very similar what we've done with Docker. So let's get AWS and let's do Calico. So I'm just going to use the right kube config. Ooh. I think because the instance is still initializing. Yes. We have to wait because the API server is not ready yet. So we have to wait for this to be actually ready to accept our requests. Well, slowly but surely. Let's try again. No. So I'm gonna do instead, I'm gonna get our nodes and I'm gonna watch it to make sure we actually have it up and running. So as you can see, if you actually use an external infrastructure provider, which is not your local machine, it's going to take a bit longer because there is like this interaction with API endpoints. There is a lot of, I wouldn't say a lot. To be honest, we've provisioned the Docker cluster within minutes, and the AWS we're going to provision in less than 10 minutes anyway. So it's still very, how can I say it, reliable. So yeah, we have the instance. Good. So at this moment, let's deploy our Calico. And let's wait for our instance, our nodes to be up and running. Just gonna take seconds. We just need to wait for our containers to be up and running. And meanwhile, actually, before actually waiting for that, we can actually add worker nodes to our cluster. So I'm just gonna apply that because it's gonna take maybe 2 minutes. AWS workers, and we can look at that actually. So what I've done here, I'm actually adding 2 nodes, 2 worker nodes to our cluster, running version 115. And again, it's going to be a deployment and machine deployment. And what else can I focus on is actually this joint configuration again. What we do, we have a cluster, we invoke kubeadm with a joint operation. So now if we do, if I get all my machines, I'll be able to see that these are provisioning 2 worker nodes. And if I'm going to AWS, I'll be able to see 2 worker nodes, which are, one is pending. I think that one is initializing. And then result is going to be, if I get all my nodes, this is ready. At some point, I'm actually going to have my master nodes being up and running here very soon. So what we've actually created here, with one management cluster, we provisioned a Docker cluster, Kubernetes cluster, and an AWS, I wouldn't say Docker cluster, a Kubernetes cluster which is running on top of Docker, and a Kubernetes cluster which is running on top of AWS. So if I do this again, I'm actually seeing my nodes and they're going to be ready within seconds. So I think this is going to be concluding my demo. I'm not going to wait for them to be ready. All of them, they're ready. Pretty quick. So this took around 10 minutes to provision 2 clusters, fully working clusters. So what I could do after that is deploy my application. So I'll give it to the developers and be like, deploy whatever on top. So before I summarize everything, I would like to leave you with a few takeaways about ClusterAPI. Now, ClusterAPI works on the building blocks principle. This means that it uses the available resources from Kubernetes and available API endpoints rather than embedding the code within the Kubernetes repository. I think this is one of the main features of ClusterAPI, which made it so efficient and effective in a short amount of time. Another thing about ClusterAPI is cloud agnostic, and this is one of the things why it's so important for Conde Nast to prototype a tool like ClusterAPI. It actually provides this common interface to plug in into different infrastructure vendors while having minimal changes to your manifests. And obviously, the last thing is the ClusterAPI is experimental. It's been around for half a year, but it has a lot of interest from the community. If you have a use case for ClusterAPI, please give it a try and provide feedback to the community, because pretty sure like any features you request now, they're going to be quite soon in the next releases. So today we talked about ClusterAPI and how we actually prototyping it and what use case we have for it at Conde Nast. We talked about its workflow and the concepts it introduces, such as management cluster, target clusters, and controller managers. And we talked about the way we actually can specify our manifest or YAML configuration for our ClusterAPI. Here are some of the resources to help you get started. This is the ClusterAPI book from which you can actually spider into different resources for different infrastructure providers or bootstrap providers. And as well, this is actually quite new. I have written a ClusterAPI, a guide on how to get started, which is available on Medium. So this is going to be the short link to it. Now, I would like to take this opportunity to say that we are hiring. If you would like to know more about the projects we do, if you have any more questions about the topic, you can visit the link provided here, or you can contact me on social media. I'm going to be available on Twitter and LinkedIn. And I think that's it. Thank you.